Hello and welcome to section 5.5, the last section of chapter 5 that we'll be doing. Section 5.5, we're going to look at inverse trig functions. I've broken this section into 3 smaller video segments. That way, if you need to go back and review the inverse sine function or the inverse cosine function or the inverse tangent function, you'll have quick reference. You wouldn't have to sit through, a half an hour or 45 minutes of videos. You can just pick the ones you need. This first video, we're going to focus on the inverse sine function. So let's reproduce our sine curve. If we do just half of the period of our sine curve going to the right and go the opposite way, we get something that looks like that. It looks kind of upside down from our normal sine function. But the reason I draw it as such is because of what we're going to be focusing on for the inverse sine function. Specifically, we are only looking at the part of the sine curve that goes from negative pi over 2 up to pi over 2. So formally, I'm going to restrict the domain to negative pi over 2 up to pi over 2. And by doing that, if I'm only looking at the green area here, then my range goes from what? It goes from negative 1 to positive 1. Those values in between. So let me give you a formal definition to start. I'll kind of give you the revised version of what it is we're really looking at when we do this inverse sine function, based on this idea of where we're restricting the domain and range. So definition says the following: the inverse sine function is the function we write it as the following. Our word sign with a little -1 exponent. When we see something like this, this is telling us the inverse sine function. That's its notation. So this function with domain -1 to 1 and range minus pi over 2 to pi over 2 is defined by sine inverse of some value x equals y implies that sine of y is equal to x. I know what you're saying. What in the world is this guy talking about? None of this makes sense. First we were restricting domain to minus pi over 2 to pi over 2. Range was -1 to 1. Now we switched them. Why is that? Well, if you remember, when we have inverse functions, their domains and ranges switch. So all it's saying is that if we have some function, we take the sine of that value. In order to get back to the original value, we'd have to do the inverse sine. So for example, if I have 3 and I square it, that gives me what? 9. The only way to get back to the original value is to do the opposite function. The opposite function of squared is square root. So 9 square root gets me back to 3. that's essentially what all this is talking about. It's the math of it. Maybe sounds a little bit confusing, but this is the formal definition. Now, what is the most important thing that we have to remember when we're dealing with the inverse sine function? And it's the following. If I am restricted to my domain of minus pi over 2 to pi over 2 on the unit circle, where is minus pi over 2 to pi over 2? It's the right half of the unit circle. If we were doing problems that involve the inverse sine function, our final answer has to end up somewhere on the right side of that unit circle, or we have the wrong answer. It has to fall in that portion. So first, let's look at some examples. If I want to find each value, and if first I have that the sine inverse is equal to 1/2. So what that is asking me is on this right half of the unit circle, where is my y value equal to 1/2, positive 1/2? And you can go back to your handout from the first day. If you know them already, if you want to do the Pinterest trick, whatever works for you, that's fine. But we want to know on the right half of that unit circle, where is sine equal to 1/2? Well, that's what? It's pi over 6. So it's, instead of me saying, what's sine of pi over 6? Oh, it's 1/2. I'm going the opposite way. I'm saying, how do I get to 1/2 if I'm taking the sine of some value? Now, what if I have the following? Sine inverse of minus 1/2. And you can see why this is important that we're sticking on the right side of the circle, because technically sine of 1/2 could have been either pi over 6 or 5 pi over 6. But it has to be on that right side of the circle, so the only possible answer is pi over 6. In this case, where is sine inverse minus 1/2? Well, that is at minus pi over 6. So we're just going to use the minus values for our terminal points now. Instead of saying 11 pi over 6, we're not going to do that. We're just doing either pluses or minuses to end up on that right side of the circle. And third, what if I have sine inverse of 3/2? Well, this is the unit circle, right? Unit circle means what? 1. Which means that this value in our range we know is -1 to +1. I don't have any value on the right half of my unit circle that would ever get me 1.5, because the biggest value I ever have on the unit circle is 1. So this we say it's not defined. So there is no value. If you type this on your calculator, you're going to get an error, because there's no value in radian mode where 1.5 we can find a sine inverse value for it. So hopefully that's clear. The biggest thing, dealing with the right side of that circle. Let's look at another type of example. So that's the basic. If we're just given a sine inverse of some value. But now, what if we have examples like the following? If I want sine inverse of sine of pi over 3. So I'm taking the sine inverse function of the sine function. So they don't necessarily just cancel out. They could, but I'm not going to give you that shortcut, because I'd rather have you figuring them out piece by piece, so then you never get it wrong, as opposed to just saying, oh, this must be a situation where they cancel out. So I'm just going to look at this one first. Sine of pi over 3. So sine of pi over 3 is what? So sine of pi over 3 is going to be square root of 3 over 2. So again, if you want to do the Pinterest trick, if you want to look at your chart, if you have it memorized. But if we look at just sine of pi over 3, that's equal to square root of 3 over 2. Now bring this piece down. Sine inverse of square root of 3 over 2. So on the right, so this is like the problems we were just doing. So we've simplified this one, now we can do this problem. So where on the right half of the circle is sine inverse the square root of 3 over 2? Well, it just so happens it is pi over 3. So in this situation, they would have canceled each other out. But again, I don't want you to rely on that shortcut because it won't always work like that. And let's look at an example like that. So let's say we have sine inverse of sine of 2 pi over 3. So again, the first thing I want to do is just focus on this portion here. So sine of 2 pi over 3 is what? Sine of 2 pi over 3, as above, is also square root of 3 over 2. Then we bring the sine inverse portion down. So where on the right half of the circle, and I hope by now you're tired of me saying right half of the circle, because that's how important it is for these sine inverse problems. So where on the right half of the circle is sine equal to square root of 3, positive square root of 3 over 2? Well, it's also pi over 3. So these two problems end up with the same result, but you can see we get there very differently. So don't just think that because they're inverse functions, they can just cancel out and you're left with the number that's there, because we are restricted to the right half of that circle. All right, I'm sure you've heard me say that enough. Work some more examples. Again, practice makes perfect on these guys. I'll see you in video 2 for the inverse cosine function.